Okay, baseline logic is the proof of science. There's prediction, which is the dotted line. So if I do nothing, the dot stays here. There's verification, which is the proof. If I take the intervention away, then the behavior goes back to baseline. I just verified the prediction was right. And then replication is the repeat. So I put the intervention back in and it worked again. So it wasn't a fluke. It's proof that the intervention is what's changing the behavior. Reversal ABA or ABAB designs are the strongest for experimental designs. They're used for reversible behaviors, not skills. And they're never used for danger, like PICA or SIB, because you don't want to repeat the behaviors again if they're dangerous for ethical reasons. Multiple baseline is the staggered one, so it's used for skills, reading, or dangerous behavior if you have to. So there is like a picky note though. It's if baseline 2 moves when you start intervention 1, you have a lack of functional independence, which is bad. So you want to make sure you're observing the baselines to make sure that they're not, or that they are doing what they need to be doing in this reversal design, which is going back to what they need to go back to for it to be proven that there's verification and then that there's replication. Alternating treatments is the fast one, so there's no baseline needed and it compares treatments. The IOA formulas I'm probably going to need to remember are total count, which is the small number versus the big number times 100. It's the weakest over the vague. Mean count per interval, I'm going to need to remember it's average of every interval's IOA, which is the middle ground. Exact count, I'm going to need to remember it's 100% of the intervals versus, or over top of the total amount of intervals, and then times 100. It's the strictest or the hardest. Compound schedule. This is going to go off of is it simultaneous? Is there a sequence to it? And does there signal an SD? Is there a signal or an SD? Concurrent, yes. It is simultaneous. There's no sequence to it though, and it does not signal an SD. So concurrent is that choice. Multiple does not have schedules going simultaneously, and it's not in an order, but it does signal an SD. Mixed is not simultaneous and not in a sequence. It does not signal an SD. Chained is not simultaneous. It does have a sequence. It goes in order, and you do have signals for chained. And tandem is also in order, but there's no SD and it's not simultaneous. Alternative is not simultaneous and there's no sequence in it, and there's also no SD. And conjunctive, there's no simultaneous, the sequence, there's no, and the SD, there's no. Okay. Open this. In a single case experimental design, the participant serves as their own control, and the demonstration of experimental control is achieved through the 3-part process known as baseline logic. The logic allows the researcher to rule out confounding variables and establish a confounding functional relation between the treatment and the behavior change. Prediction is the first component of baseline logic, defined as the anticipated outcome of a future measurement of behavior. If the environmental variables remain unchanged, Establishing a stable baseline is critical because it provides the basis for this informed guess. Stability is characterized by low variability and the absence of a clear trend that would suggest the behavior is already moving toward the desired direction. If a behavior is already improving in the absence of treatment, demonstrated by the ascending trend for a skill or descending trend for a problem behavior, an intervention may not be scientifically or clinically justified, as the learner is acquiring the skill through natural contingencies. The predictive component requires the observer to project the current data path into the future. If the baseline data for a student's tantrum behavior is steady at 10 minutes per session, the behavior analyst predicts that without intervention, the tantrums will continue to last approximately 10 minutes in subsequent sessions. This projection is essential for creating the control against which intervention's effects will be measured. Verification confirms the impact of the independent variable. It involves demonstrating that the baseline levels of responding would have remained at their predicted levels at the independent variable, or had the independent variable not been introduced. In the context of a reversal design such as ABA, verification is achieved when the behavior analyst withdraws the intervention and observes the behavior returning to the original baseline levels. This rebound provides the change observed during the intervention phase and proves that it indeed it was caused by the treatment and not by the extraneous event, such as a change in medicine or classroom policy that occurred simultaneously at the treatment. A significant challenge in verification is the concept of irreversibility. If a behavior analyst teaches a child to read, which is a permanent skill, withdrawing the instruction method will not result in a return to baseline illiteracy. In such cases, a reversal design cannot be used for verification, and alternative designs like multiple baseline must be employed. Furthermore, for behaviors that are dangerous, such as self-injury or choking, the withdrawal of a successive treatment for the sake of a verification poses a profound ethical dilemma, as the practitioner must prioritize client safety over experimental proof. Replication is strengthening reliability and generality. It's the third and most robust component of baseline logic, requiring the repeated demonstration of an effect within the same experiment. It strengthens the case for a functional relationship by showing that the independent variable can produce the same behavior change multiple times. In an ABAB design, the second B phase serves as the replication of the first B phase. If the behavior decreases during the first treatment phase, it returns to baseline without the withdrawal phase and then decreases again during the second treatment phase. The likelihood of the results were due to chance is drastically reduced. Replication can be categorized into intra-subject replication, which builds internal validity by repeating the effect with the same individual, with intra-subject replication, which builds external validity by repeating the effect across different individuals. External validity is the degree to which a study's results are generalizable to other subjects, settings, or behaviors. For a professional preparing for the board exam, it is vital to remember that replication is not about getting the same outcome. It's about getting consistent outcomes through repeated manipulation. The matrix of baseline logic in single case designs. So you have prediction, which is a logic component, And the mechanism of that action is going to be the projecting the future baseline path based on stability. It's used to determine if intervention is needed, and it's going to show up as like a flat or steady baseline trend line. Verification is proving behavior would have stayed at baseline without treatment, essential for reversal designs and proving control, and the return to baseline levels upon the treatment withdrawal. Replication is repeating the treatment effect to rule out flukes. It's necessary for internal validity and generality. Second or third treatment phases showing matching results. Single case experimental designs are differentiated by how they arrange phases to demonstrate experimental control. The choice of design is influenced by the nature of the target behavior, the setting, and the ethical constraints. A reversal ABA design masterclass. The reversal design is characterized by repeated measures across the baseline phase A and the treatment phase B. It's often considered the most powerful design for proving a functional relation because it directly demonstrates the on-off control of the treatment over the behavior. An ABA design is the most basic reversal, consisting of just the initial baseline and intervention and then the return to baseline. While it satisfies the requirements for prediction and verification, it is often professionally criticized because it ends with the client in non-treatment condition. ABAB design, so by adding that second treatment phase, the behavior analyst provides replication and ensures that the client finishes the study with the beneficial intervention in place. The BAB design is when a client presents with a behavior that is too dangerous to allow for baseline phase. So like choking. When a treatment is often being implemented by the staff, the BAB design is used. So it's being with treatment, it then moves to a baseline for verification and then returns to treatment. The limitation of this is design that does not allow for pre-intervention baseline, which can make it harder to evaluate the initial magnitude of change. Multiple treatment reversal design is involving comparing two or more distinct treatments with a reversal framework. That ABAC-AB design, it is particularly useful for identifying which treatment is superior, but it's highly susceptible to sequence events where the results of treatment C are influenced by the preceding treatment B. When we're talking about the multiple baseline design, it is the most frequent alternative to reversal because it establishes control without requiring a withdrawal phase. Control is demonstrated by staggering the introduction of the independent variable across at least 3 independent tiers. So it goes across behaviors, which is intervening on different behaviors of a person. So like teaching mands, then teaching tax, then teaching interverbals. And then across settings, it's gonna go the same behavior in different places, schools, playground, home. And then across participants, the same behavior across people, teachers, parents, texts. The critical requirement for a valid multiple baseline is that the tier must be independent. If teaching a child to mand at school causes them to automatically start manding at home, generalization, the home baseline is lost because treatment could be introduced, which ruins the demonstration of the experimental control. For the BCBA candidate, the visual giveaway is the design being a staircase effect on a graph, where each subsequent tier begins treatment later than the one above it. So that is for multiple baseline design. For multiple probe and delayed baseline variations, when daily data collection across multiple tiers is too costly, time-consuming, or might cause like practice effects where the learner gets better but just by doing the baseline tasks, the multiple probe design is indicated. So instead of that continuous data, the behavior analyst takes occasional probes to ensure the behavior is stable before introducing treatment to the specific tier. So it's a delayed, and then when you're talking about the delayed multiple baseline design, it's used when a researcher decides to add a new baseline tier and an existing study already in progress, often because of a new participant becoming available or a new setting is identified as relevant. Alternating treatments, which is a multi-element design. The alternating treatments design allows for the rapid comparison of two or more treatments by alternating them in a randomized sequence. This design is unique because it does not require a baseline phase, though one is often included, and does not require steady state responding before switching conditions. Experimental control is shown through visual differentiation between the data paths. If the data path for treatment A, for example, is consistently higher than the data path for treatment B, a functional relation is established. The greatest risk is the design in multiple treatment interference, which occurs when a participant's response to one's treatment is confused or altered by the presence of the other treatments being used in the same time frame. Changing criterion design for stepwise mastery. The changing criterion design is used to evaluate the effect of an intervention on the gradual increase or decrease of a skill already in a learner's repertoire. After baseline, treatment is implemented in subphases where reinforcement is contingent on meeting a specified level of behavior, which is the criterion. Control is demonstrated when the behavior changes in sync with the new criterion levels. The design is ideal for shaping behaviors like the number of miles run or the number of math problems completed independently. And then just a quick summary of experimental design characteristics. Reversal ABA is the withdrawal and the reintroduction of treatment. It's probably best used when behavior is reversible or withdrawal is safe. And there's the major risks or the confounds could be ethical risks and irreversibility. Multiple baseline is staggered across independent tiers. Its behavior is permanent or withdrawal is unsafe. Inter-subject and setting generalization is major risks and confounds. Alternating treatments demonstrate control via consistent separation of data paths. It's best used when comparing multiple treatments quickly, and the major risks or confounds, it's multiple treatment interference. Changing criterion demonstrates control via behavior matching stepwise criterion changes. It's best used when shaping or increasing existing skills. And the major risks and confounds, behavior shifts too fast or too slow. Inter-observer agreement, ensuring measurement reliability. Inter-observer agreement is the gold standard for verifying the data are believable and the operational definitions used by observers are clear. It involves two or more independent observers recording the same behavior at the same time and calculating the percentage of their agreement. High IOA, typically 80% or higher, suggests that the measurement system is reliable and free from bias or observer drift. IOA formulas for event recording. For behaviors that are discrete and counted, such as hand raising or the number of correct responses, 3 primary formulas are used. Total count IOA, calculated as smaller count or larger count, times 100. This is the simplest but least precise method because it does not prove the observers were counting the same instances, only that their final tallies were similar. So that is, total count is smaller count divided by larger count and then times 100. Mean count per interval, IOA, is the session is divided into intervals and the agreement is calculated for each interval and then agreed. Mean count IOA, so interval 1%, interval 2%, plus interval 3% plus interval 4%, all over the number of intervals times 100. Exact count per IOA, or exact count per interval IOA, is the most conservative measure as it only counts intervals where the observers had 100% matching counts. So the exact count IOA, matching count intervals over the total intervals times 100. So if you got 3 out of 2, you would do, or if you got 2 out of 3, you would do 2 out of 3 times 100. Interval by interval IOA, this looks at agreement on both the occurrence and the non-occurrence of behavior across all intervals. It is suitable only for moderate rate behaviors, so 40 to 60%. The interval IOA formula is going to be the total agreements, so yes over yes, no over no, over the total amount of intervals times 100. So when a behavior is recorded using interval systems like partial or whole interval recording, the choice of the formula must account for the behavior's rate to avoid that chance agreement inflation. So that's where interval by interval IOA comes in. Then you also have scored interval IOA, which is known as occurrence IOA. It's the formula that ignores the no over no agreements and looks only at intervals where at least one observer scored a yes, and this prevents falsely high scores for low rate behaviors like anything greater than or equal to 30% occurrence, where observers might agree on no 95% of the chance alone. And then there's also unscored IOA, known as non-occurrence IOA. This one's the opposite. It ignores the yes agreements and focuses only on the no recordings. So this is essential for high rate behaviors where the goal is to ensure observers agree on the behaviors, like when the behavior stopped occurring. So the score interval is looking at when at least one observer said that something did happen, and then the unscored intervals are looking at when at least one observer says something didn't happen. IOA for timing and trial-based measurements. So there's also total duration IOA, which is calculated as the smaller duration over the larger duration times 100, and then similar to total count, it's the simple, but it lacks the granularity. Then you also have mean duration per occurrence. So same thing, the average that agreement for each individual behavior or event, making it the preferred choice for behaviors with highly variable durations like tantrums. And then you have trial by trial IOA. Specific to discrete trial training, this calculates the agreement based on the outcome of each interval trial. So trial by trial IOA is trials with agreement over the total amount of trials times 100. Low rates are, you're going to have your scored interval IOAs. It's going to exclude chance of no agreements. High rates are your unscored interval IOAs, excluding your chance of yes agreements. Moderate rate is going to be interval by interval IOA, standard measure for balanced data. Variable duration is going to be mean duration per occurrence, which is the most precise for timing discrepancies. And then discrete tries, trial by trial IOA, compares accuracy per learning opportunity. Okay. Compound schedules of reinforcement signaling order and choice. Compound schedules combine two or more basic schedules, FR, VR, FI, VI, and create complex reinforcement contingencies that more closely resemble the natural environment. These are fundamental for teaching resilience, choice making, and complex skill chains. Concurrent schedules provide two or more reinforcement contingencies simultaneously for two or more different behaviors. This allows for the study of choice behavior. For example, a student can choose to work on math or read. So if they work on math, it's an FR5. So after 5 problems, they will get reinforced. And if they do reading, it's a VI2. So it's a variable interval. So after every 2 minutes or so, they will be reinforced for reading. The student will allocate their time according to the matching law, focusing on the task with the richer or more immediate reward, which is probably FR5 if they're fast at math, but it could be the VI2, which is reading. But those are concurrent schedules. So it's providing two or more reinforcement contingencies simultaneously for two or more different behaviors. Alternative schedules reinforce behavior when the requirement of either a ratio or an interval schedule is met, whichever comes first. If the schedule is FI5 or FR50, the student gets reinforced if they hit 50 responses before 5 minutes pass, or if they get to 5 minutes and they have made at least one response, they will get reinforced for that alternative schedule. So again, alternative schedules reinforce behavior when the requirement of either a ratio or an interval schedule is met. Conjunctive schedules, these require the completion of both a ratio and an interval schedule before reinforcement is delivered. So in a marathon example, a runner must run 26 miles and do it within a certain time limit to receive the medal. Conjunctive schedules require the completion of both a ratio and an interval schedule before the reinforcement is delivered. It's different because the one above, alternative, is either a ratio or an interval schedule. In conjunctive, they have to do both. And then when you have successive alternating schedules, you're going to be looking at multiple schedules and mixed schedules. Multiple schedules involve two or more schedules that alternate with being signaled by a distinct discriminative stimulus. So for example, when a praise card is green, the student is on an FR1 schedule. And when it's red, they're on extinction. So the student learns to discriminate between these conditions based on the SD, seeing that green card and the red card. So multiple schedules involve two or more schedules that alternate. That's it, with each being signaled by a SD. Mixed schedules are identical to multiple schedules, but they have no signals. So the learner does not know which schedule is active and must continue responding to find out when reinforcement will occur. This builds behavioral persistence, but it can increase frustration. So mixed schedules are identical to multiple schedules, but they have no signal. The learner does not know which schedule is active and must continue responding to find out when reinforcement will occur. There's also sequential ordered schedules, so ones that have an order to them. Change schedules and tandem schedules. Change schedules require a series of behaviors to be performed in a specific order, where each step has its own SD and serves as the conditional reinforcer for the previous step. So you complete step 1, great job, let's move on to step 2. You complete step 2, great job, let's move on to step 3, and so on and so forth. On the final step results in the terminal reinforcer. It's an example, or an example could be like the sequence of tasks in a drive-through. So you're ordering, then you have to pay, and then you get your food. But you kind of like each step is, you're getting you closer to that reinforcer, and you have to complete each step in order to get there. Tandem schedules are similar to chain schedules. They require sequential completion, but there are no signals between these steps this time. So the learner must finish step 1 and then step 2 without any external cue telling them that they have progressed. So just the analytical hierarchy of compound schedules. Concurrent, your key identifier is going to be choice. The signaling mechanism is going to be the SD per behavior. And the behavioral impact is going to be modeling preference and choice. Multiple schedules, the key identifier is that it's alternating with a clear SD, and the behavioral impact will be discrimination or stimulus control. Mixed schedules are alternating with no SD, and they're going to have flexibility and persistence. Chain schedules have a sequence and an SD between steps. They're teaching complex multi-step skills. And then tandem is sequence with no SD, but it has the independence from external cues. Alternative is the either or key identifier, and it will impact by flexibility and paths to reward. And the conjunctive, if you see both and, you can expect requirement for persistence and accuracy. The BCBA candidate must distinguish between the rationales for different types of experimental analysis. These analyses go beyond proving that a treatment works and instead explore how and why it works. A component analysis is isolating the active ingredients. It's used to identify which specific parts of a multi-element treatment package are responsible for behavior change. For instance, if a social skills program includes modeling, role play, and feedback, a component analysis would determine if modeling alone is enough or if all 3 are necessary. There's the add-in design. Elements are added into the baseline one by one, and then there's the dropout design, which focuses on redundant elements being removed to the full package to create a more efficient, lean treatment. But you're just comparing, or I guess I shouldn't use the word comparing, but you're using this design to identify which specific parts of a multi-element treatment package are responsible for the behavior change. You're trying to find what did the thing if you have multiple going at once. Parametric analysis, finding the optimal dose. It's systematically varying the intensity, frequency, or the magnitude of a single independent variable to find the most effective dosage. While component analysis asks praise or tokens, the parametric analysis is going to ask how many tokens or how much praise is the right amount. This is critical for schedule thinning as it helps determine the point at which reinforcement can be reduced without losing behavioral gains. So it's basically like, how many things can we get you to have before you're satiated with this? Or how many things can you do before reinforcement is not reinforcing anymore? Comparative analysis, treatment versus treatment. It directly compares the relative effectiveness of two or more different interventions that are not part of the same package. This is commonly achieved using an alternating treatment design. An example would be comparing the effectiveness of a timeout procedure versus response costs for reducing verbal aggression. So you want to, when you're looking at questions, you can figure out your analysis type. So if you're looking at questions that is like, which part of this package is essential, that's the component analysis, and that deals with efficiency using parsimony and plans. Then if you have a question like, what is the best dosage for this client? That's the parametric analysis. It deals with precision and avoiding overtreatment. And then if you see a question like, which of these interventions is better? That is the comparative analysis. It's the selection of the superior treatment. Okay. Professional governance and procedural integrity. The scientific rigor of behavior analysis is preserved through high standards of procedural integrity and supervision. Procedural integrity ensures that the independent variable is implemented consistently as designed. Common threats to integrity include treatment drift, where the implementer slowly changes the procedure over time, and reactivity, where the implementer changes their performance only when the supervisor is watching. Supervision and ethics under the 6th edition BCBA standards. Effective supervision is designed as employing evidence-based training to improve the performance of supervisees in actual clinic settings. The BACB 6th edition guidelines impose strict requirements to protect the quality of these relationships. Hours in observation, at least 5% of monthly fieldwork hours must be supervised. Supervisors must observe the trainee working directly with the client at least once per supervisory period to provide performance-based feedback. At least 50% of supervised hours must be individual, which is one-on-one, and then group supervision is limited to a maximum of 10 trainees. Unrestricted work. To ensure BCBAs are capable of more than just direct therapy, at least 60% of their total fieldwork hours must be spent on unrestricted activities such as graphing data, conducting assessments, and writing behavior plans. Continuing education. Supervisors must complete 32 CEUs each year, or every 2 years, including 4 dedicated to supervision and 4 to ethics, and then to remain active and eligible to supervise. For the practitioner aiming to achieve mastery and professional certification, these concepts form a cohesive system. The choice of experimental design is not a random selection, but a strategic decision based on the behavior's reversibility and the ethics of treatment withdrawal. The reliability of the data collected within those designs must be validated through the mathematically precise application of the correct IOA formula, ensuring that detection is not a byproduct of chance. Furthermore, the interventions themselves must be refined through component and parametric analysis to ensure that they are effective and parsimonious. By understanding the nuanced differences between the either or of alternative schedule and the both and of conjunctive scheduling, or the signaling of multiple schedules versus the mystery of the mixed schedule, the behavior analyst moves from a technician role to the behavior scientist. This high level of scientific understanding, control, is what allows for the reliable, ethical, and socially significant change of the behavior in the populations we serve.